Okay, this is a really quick recording just to go over the points that we did after school session on calculations this week. We talked about titrations, and these were the points that we came up with at the end that you need to remember that will help you. So the first thing is that if you're calculating the concentration, what you need to use is the number of moles divided by the volume. The second thing is the units are really important. Concentrations are given in moles per decimetre cubed or grams per decimetre cubed. A decimetre cubed is 1,000 centimetres cubed, and most of the time you'll be thinking about, or you'll be given, volumes of solutions in either millilitres or centimetres cubed. So therefore you've got to remember that vital step of dividing by 1,000. And what else did we look at? Oh yeah, keep a track of what it is that you're calculating at the time. What I mean by that is the acid that you're working out the volume of, or is it the alkali that you're working out the volume of, or the concentration? Write it down, as well as kind of showing your working, which you'll do anyway. Write down what it is you're calculating the volume or the concentration of. And it's a really obvious one for calculations, but at the end of whatever calculation you've done, check that your answer is sensible. If you've got an answer of thousands of moles, then you've probably gone wrong somewhere. And the other thing to take into account, if you're looking for the A to A star, you need to look at the reaction equation and take into account the ratio, so how many moles of acid are reacting with 1 mole of alkali. So let's look at a few titration calculations. So the first thing that you need to be able to do is to calculate the concentration. So the concentration will either be the mass in grams over the volume, or it will be the amount, and so that will be in moles, again divided by the volume. And as I said at the start, the thing that you need to remember here is that this volume is in decimeters cubed, okay? Because the units of our concentration is going to be either in grams per decimeter cubed, or it's going to be in moles per decimeter cubed. Okay, so what you've got to make sure then is that the volumes that you're using in your calculations are in decimeter cubed. And what that means in practice most of the time is that you're dividing an amount or a volume in centimetres cubed by 1,000. What you're doing is dividing by 1,000 if you're trying to get in decimetre cubes. So in the textbook on page 227, it gives you the example of 1 gram of sodium hydroxide, so 1 gram of NaOH, and that is dissolved in 50 centimetres cubed of water. So the next thing we need to ask is, what do we know and what can we find out? Okay, so what do we know? Well, we know a mass and we know a volume. And from the equation that we looked at before, we know that the concentration is equal to the mass divided by the volume. Okay, so we've got a mass of 1 gram. We've got a volume of 50 centimetres cubed. But remember, the other thing that we said is that to calculate this, we've got to get back to decimeters cubed, so we're going to have to divide by 1,000. So our our volume is going to be 50 divided by 1,000 to get decimeters cubed. And 50 divided by 1,000 is 0.05 decimeter cubed. So therefore, Our concentration is going to be 1 because our mass is okay, divided by 50 divided by 1000, which is 0.05, and that is equal to 20 grams per decimetre cubed. The next example in the textbook says calculate the concentration when 0.05 moles of sodium hydroxide is dissolved in 25 centimetres cubed of water. So what do we know and what are we trying to find out? We know the amount in moles, which is 0.05, and we also know, so we know N, and we also know the volume. But at the moment, our volume is in centimetres cubed, and so the first thing that we need to do is divide that by 1000. So that's equal to 0.025 decimetres cubed. So therefore, to work out the concentration, we go back to our original equation. Our concentration equals the number of moles over the volume, and we worked out that we've been told that our number of moles is 0.05. We've worked out that our volume is 0.025. So we divide one by the other, and we get 2 moles. Oh, I'm not going to fit this in, sorry, per decimetre cubed. And one of the things that I said when we had this is whatever you do, work out what do I know. So when you get an exam question, just find, is there a concentration in there? Is there a volume in there? Is there a mass in there? Is there a number of moles in there? What can I find out from the equation? And the next thing I said to everybody was that whether you can actually answer the question to the end or not, if you can find a volume or a number of moles or a mass or something, then stick it into an equation. You're not going to lose any marks just by coming up with any kind of equation. So if you've got a concentration, you've got a number of moles and you've got a mass in there, even if you can't do the rest of the question, then at least just calculate that and write it down and put it somewhere. Show that you know that you've got to calculate V by dividing by 1000. You know, do something, stick something on the exam paper, even if you think that you can't do a complicated titration question. However, let's do a titration question. So if we look purely at the calculations here, so this is the one on page 228 of the textbook. And what it says is that 25 centimetres cubed of some 0.10 moles per decimetre cubed sodium hydroxide was completely or exactly neutralised by 20 centimetres cubed of hydrochloric acid. But we don't know what the concentration of this is. So what the question is asking you is what is the concentration of the hydrochloric acid. So remember the question, what do we know? The other thing that I said is keep a track of what it is that you're doing. So let's start off with the NaOH. Let's start off with the sodium hydroxide. So we've got sodium hydroxide here. What do I know? Well, I know that my volume is equal to 25 centimetres cubed, and I remember that I have to divide that by 1000 to get my volume in decimetre cubed, so therefore I know that my volume is 0.025 decimetres cubed. So that's what I know. I also know the concentration. So I know my concentration is 0.1 moles per decimetre cubed, and I'm remembering, my pen didn't work very well there, but I'm remembering that this is the NaOH that I'm talking about here. So then I can do a bit of rearranging of equations. So I know that C equals N over V. I don't know what my N is, but I know this and I know this, so I can say that my number of moles will be the concentration times the volume, So here we go, we've got a concentration of 0.1 and we've got a volume of 0.025. So therefore I know that the number of moles of sodium hydroxide will equal 0.0025. So this is the number of moles, and this is the number of moles of sodium hydroxide. I've got to keep that in mind. Okay, so what do I know and what can I find out from here? Well, I know how many moles of sodium hydroxide I've got. I also know that when hydrochloric acid reacts with sodium hydroxide, I form NaCl, and I form a salt plus water. So the other thing I know is that 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. So that also means that if I've got 0.025 moles of sodium hydroxide, then I'm also going to have had 0.0025 moles of HCl. So what do I know? What can I find out? Okay, so I know that the number of moles of HCl is 0.0025. The other thing from the original question is I know that I've got 20 centimetres cubed of HCl. So what do I know? I know the volume of my HCl is 20 centimetres cubed. Remember, the next thing we need to do is divide by 1,000. So I know that what I've got here is 0.02 decimeters cubed, and I've got to remember that this is my HCl. So what do I know? I know my N, I know my V, I know my equation, C equals N over V. I know the concentration is the number of moles in the volume. So therefore I can work out my concentration as 0.0025 divided by 0.02, and this would give me my concentration in moles per decimeter cubed. So this is 0.125 moles per decimeter cubed.